A man is like a fraction whose numerator is what he is and whose denominator is what he thinks of himself. The larger the denominator, the smaller the fraction. My name is Taylor Avant, and today we'll be talking about common denominators and using it to order fractions and rational numbers. What is a denominator? A denominator is the bottom number in a fraction. It shows how many equal parts the item is divided into. If you take a look at the pizza, you can see it's divided into 4 parts. And each part is 1/4. Another example is shown here. We have 2/18, 18 being the denominator, as well as 50 and 3. Now that we understand what a denominator is, what about common denominators? We can add them together, in this case, which we get 3/4, because they're like denominators. And as you can see, the shaded area would be the area that we ate or so forth, because that's what we added and got. But what if we're given fractions with unlike denominators? How do we find the common denominator? By finding the least common multiple of the denominators. Now let's take a look at these delicious pizzas we see. How much pizza do we have left? Let's add them. So we have 2, 4, and 8 as our denominators. So what is the least common multiple of the 3 denominators? 16. So now what we do to the bottom, we must do to the top. As you can see what we did to the bottom, we take those numbers and multiply them across the top as well. So the 2, 1, and 4, and we get 8. Now we can place those in the fractions, the new fractions. We can add them together and get 24/16, which we can simplify down and get 1, 18 and 16, 8/16. And we simplify that down, we can get 1.5. And that breaks us down to finding common denominators. It comes in handy when ordering numbers or ordering fractions from smallest to largest. So here we have a number line, or in fractions, 3/4, 1/6, 4/6, and 1/4. We're going to be putting those fractions on this number line. And we start by getting common denominators, which is going to be 12 in this case. And again, we do to the top as we did the bottom, which turns 3/4 into 6/12, 1/6 into 2/12, 4/6 into 8/12, and 1/4 into 3/12. And we're going to number those or place those on this number line accordingly. And as you can see by doing this, we know that 2/12 is the smallest fraction and 8/12 is the largest fraction, which means if you're looking at the pizzas again, 1/6 will be the smallest and 3/4 will be the largest. Now there is another way we can do this as well, by using fraction strips. And as you can see, we're going to shade the area of all 4 fractions here. By doing this, you can see that 3/4 is the largest and 1/6 is the smallest again. And of course, 4/6 is always going to be larger than the 1/4. As you can see, common denominators are essential to adding, subtracting, multiplying, and even ordering them. So thank you so much. I'm going to pass this over to Michaela.
Thank you, Taylor. I'll be talking about rational numbers. My name is Michaela Allen. Rational numbers can be written as a ratio of two integers, and neither of the numbers can be zero. How many different rational numbers are given in the list of 5 fractions? 2/5, 3, -4 over -10, 39 over 13, and 7 over 4. Well, 2/5 is equal to -4 over -10, and 3 over 1 is equal to 39 over 13. And there are 3 different rational numbers, 2/5, 3, and 7 over 4. 3/5 is a ratio, and 0.35 is a rational number because it can be written as 35 over 100. Fraction strips 2/3, 4/6, and 6 over 9 represents the same number. 1 point on the number line can be expressed by identifying many fractions, like -3.5, a half, and 4.5. 2/3 and 10/15, and a half and 5/10. Since their numerator and denominator are different, however, the fractions are equivalent fractions. They both represent the same rational number. When we say the rational number of a half, we really mean the rational number represented by the fraction a half, or any fraction that is equal to a half. Set of rational numbers is denoted by Q. Q is the quotient by like 3/4. Integers in element of I is identified with the rational number n over 1. Integer I is a pair subset of the rational number Q. The Venn diagram of the set of n is equal to natural numbers, W equals whole numbers, I equals integers, and Q equals rational numbers. So any numbers that can be represented by a fraction of any of the equivalent fractions is a rational number. Now to Alicia.
Thank you, Michaela. Hello, my name is Alicia Byers. Today I'm going to be talking about fraction models and fractions in simplest form. Quick overview of fractions. Fraction simple tells us how many parts of a whole we have. The top number is called the numerator. It tells how many equal parts of a whole you are describing. The bottom number is the denominator. It tells us into how many parts of a whole has been cut. Fractions first arise in measurement problems, where they can express a quality that is less than a whole unit. The word fraction comes from the Latin word fractio, meaning the act of breaking into pieces. Fraction models are a visual model showing a fraction or fractions. Some popular representations of fraction concepts are colored regions, fraction strips, fraction circles, the set model, and the number line. A representation of fractions must clearly answer these three questions. What is the unit? Or which is the whole? Into how many equal parts the denominator has the unit been subdivided? How many of these parts, the numerator, are under consideration? The colored regions, which I have shown right here, choose a shape to represent the unit and then divide the shape into subregions of equal size. Colored region models are sometimes called area models. And then we have the fraction strip, which they would be broken down into what the fraction would represent, like 1/2. The colored is the numerator on the top, and it divides the strip into 1/2. The same way with the 1/3 and the 3/4. Here is the number line. Assign the point, and I have one that's showing 1 to 2 on the number line. So determines all the points corresponding with the integers. The unit is the length of the line segment from 1 to 2. It also is the distance between successive integer points. And then we have the set model. Let the unit set U of objects. Recall that U denotes the number of elements in U. And the A, which is in the black line, these three, A of U represents the fraction A over U. For example, the set of 10 apples shown contains a subset of 3 that are wormy. Therefore, you would say that 3/10 of the apples are wormy. Here's some fractions of the fraction strip practice examples. The first one represents 1/3, the second one 2/5, and the third one is 9/15, which 9/15 you can break down into simplest form, which if you divide the 9 and the 15 by 3, that'll be broken into 3/5. Fractions in simplest form. A fraction in simplest form when the top and the bottom cannot be any smaller while still being whole numbers. These are examples of fractions broken down in the simplest form. 2/4, if you divide both by 2, you'll get 1/4. A fraction in simplest form is also said to be in lowest terms. We avoid using the term reduced form because it is mistakenly suggests that the fraction is smaller than the equivalent one that is not in simplest form. There is 3 methods to determine the simplest form. Divide successfully by common factors, which Taylor talked about earlier. Divide by the common factors in the prime power factorization. And the third method is divide by the greatest common divisor. And on my last slide, I have examples where you can break down into simplest form. The 4/6, if you divide each of those by 2, you would get 2/3. 2/10, if you divide each of those by 2, then that would be 1/5. 21/28, if you divide both of those by 7, you would get 3/4. 10 over 15, if you divide both by 5, you would get 2/3. 6/18, if you divide both of those by 3, you would get 2/9. 4 over 8, if you divide by 4, you would get 1/2. 16 over 20, if you also divided that one by 4, you would get 4/5. 7 over 14 divided by each by 7 would be 1/2. 6 by 15, if you would divide both of those by 3, you would get 2/5. And the last one, 12 divided by, or 12 over 20, if you divided both of those by 4, you would get 3/5. That is all of my presentation. Thank y'all all for watching. Tonight we have went over fractions in simplest form, fraction models, common denominators, and rational numbers.